All right, we're talking about probability addition rule. This is the second video, part 2. We talked before about mutually exclusive. Two events are mutually exclusive if they have no outcomes in common, or the probability of A and B is 0. Okay, which we looked at being mutually exclusive. The probability of rolling a odd or a 3. This is not mutually exclusive because a 3 is odd. So these are not mutually exclusive. But right here, probability of rolling an odd number or a 4. These are mutually exclusive because it's not possible to do both of them. Okay. And then we talked about the addition rule before. The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. And of course, if they're mutually exclusive, the probability of A or B is just the probability of A plus the probability of B. And here's Venn diagrams. These are not mutually exclusive because there's an overlap. This part in the middle is shaded by the red and shaded by the black. So there's some that do both. Whereas this is mutually exclusive right here. There's no commonality between the two events. All right, so in this one here, we're going to hit more about mutually exclusive, like number 1 here. Describe or decide if the events A and B are mutually exclusive or not mutually exclusive. A die is rolled. Okay, the result is 3. The result is an odd number. We actually just did this. These are not mutually exclusive because it's possible to do both. A 3 is odd, so if I roll a 3, I'm doing both of these. Okay, number 2. Decide if these are mutually exclusive. A date in Philadelphia is selected. A is that it rains that day. B is it snows that day. Okay, well, I don't know if you know much about weather, but there's times where it rains and then it turns into snow, and there's times when it snows and it turns into rain. So these are not mutually exclusive because they both could happen. Not mutually exclusive. Number 3. Okay. Decide these are. A card is drawn from standard deck of 52. The result is a 7. The result is a jack. All right, these are mutually exclusive because there's no way to get a 7 and a jack at the same time. So these are mutually exclusive. Okay, number 4. Decide if these are mutually exclusive. A person is selected at random. What's the probability that their birthday's in the fall versus their birthday's in October? Well, October is in the fall. So if their birthday's in October, you're doing both of these. So they're not mutually exclusive because you can do both. Okay, number 5. Are these mutually exclusive? A student is selected at random. A, the student is taking a math course. B, the student is a business major. Okay, I would say there is a business major that is taking a math course. So these are not mutually exclusive. It's possible to do both. Okay, so maybe you get the hang of it there. And number 6. Cards drawn at random from a standard deck of 52 playing cards. Find the probability that the card is an ace or a king. The probability that it's an ace or a king. Okay, well that's going to be the probability that it's an ace plus the probability that it's a king minus the probability that it's both. Well, you can't do both because these are mutually exclusive. So it's just that right there. So the probability of getting an ace, there's 4 of those out of 52. The probability of getting a king is 4 out of 52. So I add these together. And so like we talked about before, we just add the top numbers. 4 plus 4 is 8. This is going to be 8 divided by 52. And that simplifies because 4 goes in both of those. So that'd be 2 over 13, I believe. So right there, B. Yep, that's right, B. Okay, 7. A card is drawn at random from standard 52 playing cards. Find the probability that the card is an ace or a black card. Probability that it's ace or black. Okay, this is going to be the probability that it's an ace plus the probability that it's black minus the probability that it's ace and black. It can be both, so these are not mutually exclusive. So the probability that you got an ace, there's 4 aces out of 52. The probability you have a black card, there's 13. No, I'm sorry. There's 26 black cards out of 52. Minus the probability that's ace and black. All right, how many black aces are there? Well, there's 2 of those. So there you go. And now you can just do 4 plus 26 minus 2. 4 plus 26 is 30. Minus 2 would be 28 out of 52, which simplifies, it's 7 over 13 right there. Okay. Part number 8, the events A and B are mutually exclusive. All right, the probability of A is this, the probability of B is this. All right, the probability of A or B is going to be the probability of A plus the probability of B. So it's going to be 0.5 plus 0.1, which is 0.6. So that looks like C. Okay. So it's not really that difficult. Number 9, given that probability of A or B is this, probability of A is this, the probability of A and B is this, find the probability of B. All right, now this is a little bit different here. This is like some algebra stuff now. So let's write it out here. Probability of A or B equals probability of A plus the probability of B minus the probability of A and B. All right, so the probability of A or B is right there, 1/4. The probability of A is right there, 1/5. The probability of B is what we don't know. Minus the probability of A and B, well, that's 1/7. So basically, we're just going to solve this little equation here. And the way to do that is I would minus 1/5 on both sides, and that would go away. And I would add 1/7 to both sides, and that would go away. And the probability of B is going to be this right here. So this is just like algebra. So now these, I can't just add the tops and then divide because all the denominators are different. So I'm just going to punch this in the calculator here. Okay, I've got 1 divided by 4 plus 1, minus 1 divided by 5, and then plus 1 divided by 7. And change that to a fraction. 27 over 140, and right here it is. Okay. Number 10. Table list of smoking habits of a group of college students. You have man and woman. You have smoker and non-smoker, heavy smoker. Non-smoker, regular smoker, heavy smoker. If a student is chosen at random, find the probability of getting someone who is a man or a non-smoker. Probability of a man or non-smoker. All right, that's going to be probability of man plus probability that he's a non-smoker minus the probability that he's a man and a non-smoker. Okay. All right, so looking at the table, probability of a man. All right. Now, like I told you a while ago, here's my total right here. So really, the probability of a man is right here, 205 over this. But I'm just going to put 205. And then afterwards, I'm going to divide all these by 427. Plus the probability is a non-smoker. All right, non-smokers right there, 322 over this. Over that. And then minus the probability is a man and a non-smoker. So man and a non-smoker would be 135 right there, wouldn't it? So I add these, subtract this, and then I divide all that answer by 427. Okay, so let's do this here. 205 plus 322 minus 135 equals 392. Divide that by 427. And that's 0.918. 0.918. You see that's the answer. Okay, just a couple more. All right, number 11 here. It's the same kind of question. Students chosen at random find the probability of getting someone who is a man or a woman. Round the answer to 3 decimal places. All right. If they're a man or a woman, I think this is just going to be 1. I mean, it's either a man or a woman. But what you could do there, probably it's a man or woman, equals probability of a man plus the probability he's a woman, and then these are mutually exclusive, so that's it. So probability of a man, that's 189 over 411. See, here's my total down here, 411. The probability of a woman is 222 over 411. So then I add these, 189 plus 222 is 411, divided by 411 is 1. So yeah, that was an easy one. I mean, that's 100%. It's either a man or a woman. 12. All right, the distribution of master's degrees conferred by universities is listed in the table here. Assume that a student majors in only one subject. So that means these are mutually exclusive. You can only do one subject. All right, this says, what's the probability that a randomly selected student with a master's degree majored in English or mathematics? The probability that he's English, probably he's English or mathematics. All right, so it's going to be the probability he's English plus the probability he's mathematics, but you can't do both, so there's no, these are mutually exclusive. All right, probability is English. All right, that's 201 over the total, which I need to add all these up to find the total. Probability is math is 225, and I got to add all these up to find the total. Okay. So let's do it. We're going 5, 6, 12, 18, 20. Carry my 2, 4, 12, 19, 21. 2, 4, 6, 7, 9. 910. Okay, so I add these two. 201 and 225 is 426. And then 426 divided by 910. And that comes up to 0.486. The 1 does not make, oh, I'm sorry, 468. And the 1 does not make the 8 go up. So you can see the answer right there. We're in good shape. And then the last one here, 13. Okay, it's the same kind of question. All right, what's the probability of a randomly selected student with a master's degree majoring in business, education, or engineering? All right, it's probably that they're business or education or engineering. All right, these are mutually exclusive because it says you can't do both. You only can do one subject. So it's going to be the probability that he's B plus the probability that he's ed plus probability that he's engineering. And so I just add these up. So probability that he's business is 176 right here. See that? Education 222. Engineering right there 92. Divided by the total. Okay. Now, are these the same numbers from the previous question? No, they're different. So 13, 15, 21, 23, 2, 3, 12, 19, 21, 2, 4, 6, 7, 913. So you just add those up. I did them in my head, but you just do them with the calculator. Add these up. This is your total. So that goes there. I'm going to divide. So I add these up and I divide by the total. So let's do it. 176 plus 222 plus 92. 490, and I divide that by 913. 0.5366. This 6 here makes that 6 go up to a 7. So 0.537, and there's my answer right there. So we're in good shape. 0.537 right there. Okay, so that's part 2 of the probability addition rule. This was section 0.33b. If you have any questions, just let me know. I'll help you all I can. So have a good rest of the day. All right.